Well, I was thinking I was done making upgrades to my Ender 3 V2, but then I noticed today that it was doing this. Look at this Bowden tube. Watch this. When it retracts. Now I've got the retraction set kind of high at 10 right now, but look at that. See that tube going in and out? That means she ain't holding tight like she should, and that is the reason I had to turn my retraction up to 10. I think once I get this fixed, I can turn it back down to 5, because I noticed my prints were starting to get a little hairy. This print I'm printing right now looks really good though, because I have that. But then I was hearing it making some weird noises, started investigating, and saw it doing this, which I thought was really wicked. So we're going to go ahead and upgrade this to a double gear drive, since I already purchased it a while back, but I didn't think I was going to ever use it. But guess what? Now I am. Hi there, and welcome to Michael's 3D World. Let's get back after it. Let's fix these problems. Now here's all the stuff that came in the package. It came in a package like this. I'll put the link from off of Amazon where I ordered it at, or what I ordered. But it came with springs, the high tension springs, which is one of them is designed for this, but the others can be used on the bed. It's got some new nice Bowden tube with some keepers, some screws, and some Bowden tube quick locks. Looks like it comes with 4 of them. So we're gonna go ahead and get this changed. Well, it actually comes with more of that because I got one already kind of started into here. But anyway, I don't have any instructions. No instructions come with it. So what I'm going to be showing you here will be the instructional video on how to put this together and the upgrade, and we'll see how well it works afterwards. I think we'll be fine. So let's get started putting it together. First of all, we got to take the other one apart. Now I'm going to go ahead and apologize for the background noise. I've got the old Ender 3 down there that doesn't have the quiet servos running, printing me some ABS, and I've got printing my wife a flower pot on the C10, so that's a relatively big print. So far it's turned out pretty good, but let's get back to what we're going to do here. Here we're going to take, we already removed the little blue knob, as it were, and we're going to go ahead and we need to extract our filament. So I'm going to go ahead and power it back on now that I think about it. And I'm going to extract the filament out of the tube. I'm going to go ahead and turn that back up to 200. And we're going to see if we can get that pulled out of there. While that's coming up to temp, I'm going to go ahead and start taking some of this apart, I think. Now, if you guys don't have one of these little IFIXIT kits, I'll leave it in the description down below. These things are so handy. Magnetic lid, magnetic sits on the back, but it's got all the handy dandy little tools that you need. I mean, all the way from little tiny Phillips to little blades to, you know, just everything you need to work on computer stuff. It's really handy. I recommend you get one. Comes with a little bearing so you can easily turn things. It's so nice. You guys might have seen me use it in other videos. So I'm just going to go ahead and start disassembling this thing. I think we'll take the spring pressure off first, huh? Let's back this screw all the way out. Let's set that down. As you can see, there's this little bushing in here. Make sure I can get you in the shot here. There's a little bushing in here that holds the spring. Let's go ahead and back this one off now. That Bowden tube was working back and forth in there for a little while. Okay, we'll continue on here. That's the other beautiful thing about this little kit. It has some of the smallest little Allen wrenches, so you can get in here and get at these little tiny set screws that are holding the, it's dropping down. Try to keep it in the shot for you here. So we're going to go ahead and pull off the brass gear. I'm going to go ahead and get a little wrench and back this off. I believe the wrench that came with your Ender 3 will work. Sure enough. Go ahead and back that out. Go ahead and Get that out of our way. Man, that is so stuck. There. Got the material extracted. Now I can turn it back off. This should lift out of the way. That's the old plastic. Next thing we want to do is remove this plastic piece, I do believe. There's no instructions, guys, so I'm just winging this. So if I make mistakes, oops, wrong size. Just a little guy. I'll make mistakes so you don't have to. Take out that one little flathead there. We got a little butt head here. I said button, not butt head. Another little button back here. And that releases the motor. Oh, those got some little bit of weight to them. Alright, we've got that freed. Now we can put the new one piece back on. So we'll go ahead and put the flathead back where it belongs. Get everything loosely started here. Now this is an all aluminum. It's red anodized aluminum, it looks like to me. Get that one started. And the third one right back here. Sorry, my head's gonna get in the way for a second. Michael, get your big head out of the way. Your big head's in the way. Okay. So once those are back in, we should be able to tighten that right back down. Let's go ahead and tighten in our new little Bowden tube holder. There we go. Well, that's tight. And since we're not going to be using this, but I want to get this out of here so I can show you what this thing was popping back and forth quite a bit. Let's go ahead and cut all this. I'm going to replace the Bowden tube anyway, I feel. Actually, I probably wouldn't have to. I can just cut it. It's plenty long. I might as well just go ahead and cut it. I think I'll do that. Got a little Bowden tube cutter here my son left behind. You'll see this video and goes, ah! That's where it went. Yep, buddy, I got it. So we'll just take this and shove that right back in there. Now that fits nice and tight. We can check the range of motion here. Truth be told, that could be longer. We're going to go ahead and put a longer one in. Golly. There we go again. I'll tell you what, these don't let go. Good stuff. Glad they send more than one. A lot have been screwed. Alright. Now we got some new stuff here. We can go ahead and stick that in. And before we cut this one, there we go. We're going to make sure I got enough travel without any issues. So we'll go about there. Looks like there's enough in that kit to do it twice. That's good. That's good. That's good. That's good. Now to get this one out without my pet thing being a problem might be a problem. I think I'm going to go ahead and pull my pet thing off in order to make this job a lot easier. This modification I made makes it pretty easy because there's only the 3 bolts that are holding it on now. I can just set it right out of the way. I'm just going to unthread this one out of the hot end and put in a fresh one there too. Everything looks pretty good. Let's see if there's any melting going on, but that hasn't happened. Boy, those just do not let go. Now what I'm going to do, that was currently bottomed out. I'll back it off a half a turn. And I'm going to stick this right down in there and bottom it out. And we'll go ahead and put my clip in, and then I want to go ahead and tighten it. And that'll make sure that tube is down tight against that nozzle. Alright, now we got the new Bowden tube in, and we've got full range of motion here without it binding. Good. Phew! Now we're going to put the old pet thing back on. And the through bolt with the nut on the other side. Now some of you might say the nut's the person on the other side of this screwdriver. For the most part, I'd agree with you. Well, I tell you, this little screwdriver is the handiest, dandiest darn thing ever. My son has it in his IT kit, and I can see exactly why. Alright. Then we'll just have to tidy this wiring back up. Let's go ahead and work on this. Am I still in the shot? Yeah. Okay, so we mounted the anodized piece. The next thing we're going to have to do, I got me a piece of filament here, bright green. Bright green. I'll stick that right in here. And I'll show you why here in a second, because I think I'm going to need it. Because I want to get that gear in the right position. Here we go, we need the teeny tiny Allen on this one. A hex drive. That won't slip by there, are you kidding me? Well, there you have it. Let's crack these back loose. And apparently, that gear doesn't slide by with it in place. It fits that tight and close, I guess. See if I just give it a little bit of wiggle room, it'll go maybe. Now the new one, the old one had 2 screws on it, or 2 set screws. This one only has the 1. So you want to make sure you put the 1 on the flat. And the reason I've got the filament in here is because the little drive knurl that's on here, I want to make sure is in line with the filament. Before I tighten that all the way down, I'm going to go ahead and bring this stuff back up into place. Okay, tight, tight, tight. There we go. Tighten up for the second time. We do it nice because we do it twice. The guy I used to work with said that all the time. He was a riot. If you guys have been following the comments on my channel, well, Badger Bob left a comment on there I just loved. It says, if it ain't broke, don't fix it. But he prefers to say he liked to keep fixing it till it is. I think he meant is broke. That's when you know you're done. I thought that was a riot. The next little piece we have is this little guy here, which is the gear that goes on the other side of life. Back in this here area. No, yeah, no, what? How's that supposed to work? Oh. Boy, howdy do I see. So the filament comes through here. And then through there. Like that. Oh yeah. That looks good. It looks like to me we have this little button head screw. That ain't long enough. Is it? No, that ain't long enough. I just dropped it in there too. I must reuse this one. Okay, now I got to figure it out. There's a bushing like this that comes in your kit. And that slips down in here. Then your original screw goes down in there. My golly, look at this figured out. You guys might be asking, why do you keep messing with that filament, trying to stick that filament through there? And I'll tell you right now, it's because I want to. It's just that simple, it's because I want to. So it looks like we can put this back in here. Is that not going to work? What now? What now? What hell's bells? That screw ain't long enough. And it didn't come with a longer one. Yes, it did. Yes, it did. It came with a longer one. It was laying over there on the table. I didn't see it. Well, look at there. Sometimes I'm my own worst enemy. There we go. You're probably thinking now, Michael, quit trying to stick that green piece of crap in there. I'm sorry, I can't help it. There. I just want to see how things are coming together. Come together right now over me. Okay. So that's can't be bottomed out. We're gonna back that off there. That's supposed to float a little bit there. There we go. Now what's left to put back on is this spring. Now the one thing we don't have anymore is our handy dandy little knob, but oh well. Wasn't attached to it. It was fun to watch this go round and round and round. Don't go in there no more. Now what we got left to do is get the tension spring back in here. Now what they gave you is one heck of a spring. I'd be curious if I could even get it in there. I bet I can, because I'm talented like that. Whew! Whew! That's a spring, buddy! Now what screw do they have in there for that? Where'd it go? Oh, that other spring I had. I bet it was this guy here, huh? Well, I'll tell you what, that sits too long. I think it'll just pinch the filament right in half. Oh, you know what I didn't do? Son of a bee sting. That's why that went in so easy. Because there's a threaded thingamabobber here. Oh man. I'm leaving this in real time, folks. I don't care if you fast forward. I don't care. I don't care. I had a picture to look at, but I guess I'm just trying to show you I'm smart enough to figure it out. Well, from what I can tell, there is a house in New Orleans. There's a screw that you can stick right in here, and I'm going to screw right down into here. There. It bottoms out right there with about that much sticking out. What that's going to do for me is it's going to allow me to have that spring something to rest up against. Then your other screw, see right here, that'll go in there and keep that spring in place. So now, let's see if I can make this work. Let's see if that's the one to use there. I'll show you what I'm doing as I figure it out. We get that one in here like that. Just lay that in here. I'm going to go ahead and start this spring-a-jobber here. The right size hoonie haw. Alright. Can he make it? The old book written by, the old book called 15 Yards to the Outhouse, written by Willie Make It. Alright, there's going to be a lot of little tightness going on here. See if I can I want to see if I can get this back up to the top so I got some room to see if you're still in the shot here. Okay, we've got all the springs and everything where I want them. The trick's going to be, can I get this guy started back in the threaded hole I want it in? So that goes in there. I don't know. We'll see if I can make this happen. That is a stiff little spring to give you. Well, that fell right in. What the heck? That was easier than I thought it would be. I'm gonna screw this little joker back in there. Nothing can come apart, right? Yeah, that just locks in there. Bam, bam. Bam, 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 bam. Alright. I like it. Let's see if I can still thread my little plastic back through here. I think I can. I think I can. Should work. Oh yeah. The greatest of ease. You definitely want to have this tightened in place first, but I think I had it pretty tight. Yeah, it ain't going anywhere. Well, that's done. So now we got a nice little spring just like we have underneath our print bed. Puts a respectable amount of tension on things. I'm going to double check this screw to make sure it's tight. It came pre-assembled. There we go. Oh yeah. That wasn't what I'd call tight enough. There, free floats. I guess you don't want it tight, just snug and work, huh? Let's put our keeper back in here. Get our keeper. Put our Bowden tube keeper. What that does is just put tension out here to keep that Bowden tube tight. We'll just snap that back on there. Well, we got all this back together. That wasn't so bad. It's all together and tight now. Now we got a double gear drive. Now it's driving. The old style just had this little idler bearing, grooved idler bearing there. I can always switch it back if I want. But now it's got a gear down here that drives the other side, which has its own serration, so it's actually driven from both sides. More precise, I would presume. Yeah, let's run that for a while. Let's see what happens. Now I gotta tidy my wiring back up. All the colors of a rainbow. Don't you know? See, let's put a red, and we'll put a little bit of a yellow, and then we'll put a little bit of a blue. Why? I don't know, because I got them, I guess. That's no other reason. Some of you that, yeah, I think we'll put one more right back here. Some of you that don't like my color matching, I'm sorry. Back to goody good. Sure. We'll take that out now. I like it. I like it. Alrighty, wanted to give you a quick close-up of how that whole assembly looks all put together. In case you need to use it for reference. Okay, once you got it back together, you're going to have to calibrate the feed rollers because the gear and the knurled diameter here is different than the stock one. So your feed rate of filament is going to be different than it was before. I'm going to put a link down in the description. I'll show you here on the screen what it looks like. All right, I want to direct your attention to this one right here. This YouTube channel called Teaching Tech. This guy is pretty sharp, pretty technical for sure. He'll take you to go to this guy, look up this particular video, 3D printing calibration revolutionized step by step to better print quality. He covers a ton of ground on printing calibration. And the one I want to tell you about you need to look at is the Extruder E-Steps calibration. What this is going to do is tell you step by step what to do to update your stepper motor so that it's reading the right amount of steps for the right amount of feed that you're getting. Just to give you an example, mine read E93, or not E93, the E set at 93. Let me go into Octoprint here and I'm going to show you exactly what I'm talking about because this can be a bit confusing. I'll guarantee you that. It took me a hot minute to figure out what to put in. So I'm going to show you what to look for here. Because right now it says, type in an M92. And if you only receive an OK message from this alternative, you can look for M92 after M92 line after entering. So I'm going to show you what that means. So bear with me for just a second. I'm going to open up another web page here. All right, you're going to open up your if you've gotten this far with me, you probably have an Raspberry Pi with Octoprint tied to your printer, which is tied to your computer. And here's where you're going to go in here and look at that information. You're going to go to Terminal, and you can see all this code that's going to be auto scrolling by. If you go in here and type exactly what he said, which is uh, M92. So let's just type in M92 and see what pops up here. M92, enter. And what you're going to see is it says OK. And then it's going to have this E138.86. That's the number I had to put in mine when I switched over from the standard gear to this gear. That was a 93. And I'll show you why that means something. Let's go back to this one here. So when you typed in that 93 is the steps or stepper motor. I'm not sure I'm saying this exactly right, but it's what it lets the stepper motor know it's feeding out. So what you do is go on down here. You're going to measure. So for instance, you can go in here and I'm going to reset parameters here. So yours might have set a 93 originally, and you're going to put a mark on your filament. And come back from where it goes in, was what I did. This is before you put the Bowden tube on permanent. This is what you want to do. Uh, put a mark from where it goes in back 120 millimeters with a little Sharpie. And then what you're going to do is you're going to hit extrude. And what I mean by extrude is we're going to go in here in your control here. You can extrude by a specific amount. So here you type in 100 and you can click extrude. And what it's going to do is extrude 100 millimeters of filament. Well, if you don't extrude 100 millimeters of filament, that's where you need to make an adjustment. And what I'm going to do here is you're going to go, and the nice thing is it has a nice little calculator right here for you. So if your set M92 read 93, you put your 93 in here. Now you're going to put a measurement between your extruder entry and the mark on the filament. So you're going to say that, well, heck, fire, mine only measured 75 now, or 78 millimeters. So you're going to type in 78, and you're going to hit calculate. Now it's going to tell you there was 78 millimeters of filament remaining, which means, I take that back, that's not how much it fed through. You want to go how much was left. That was my mistake. So when you fed it through 100 millimeters, you hit the feed through. I know I'm probably confusing you guys, but when you hit the filament and it only went, say, 80 of your 120, that means there was 40 left, right? So there was 78 millimeters of filament remaining, which means you extruded 42 filament. So what it's going to do is there was actually, I measured out 120 and say there was 40 left. So I put in 40 here, hit calculate. That means my new E step is going to be 116.25. That's the new number I got to put in. So this little code here, you can just copy right there. You can jump right back over to your terminal and you can type that in right there. Oops. You type in the M92. The M92 space E16. So yeah, you can copy and paste that. M92 E116.25. And what that'll do is that'll pop up right here. You'll see it say OK. And then immediately after that, you're going to type in followed by the M500. And that saves this to the EEPROM. So once you've done that, once you've copied that in right here, and then followed up by an M500. Now, when you extrude 100 millimeters, it should extrude 100 millimeters. So now what you want to do is go back, put a new mark. Let's see here, where am I at here? You want to put a new mark on your filament. So you're going to come back from where it goes into the feeder, come back 120 millimeters again, and you repeat this till you get this down to it's dead on. Mark it back 120 millimeters, and then you're going to go to your control here, and you're going to extrude right here 100 millimeters again. You click extrude, and it's going to feed into that Bowden tube, right? Once it's into that Bowden, once it stops, that should have moved 100 millimeters. So if you measured out 120 and you have 20 millimeters left, you've done it. You've got it set just right. But if you didn't, then you go and plug that number in again. So because your old number is going to be 116.25, for instance. So here you're going to put in 116.25. And now let's just say there is 45 millimeters left. So it's 5 millimeters short. So the measurement between there was 45 now. And then you're going to do calculate. Now it's going to say your new E-step should be 155. So now you're going to do the exact same thing again. You're going to type in M92 E155.00 right into your terminal. You're on the terminal tab here. You're going to type it in right here and hit enter. And then you're going to follow it up with the M500. And that's going to lock it into your EEPROM. Now you're going to run through the step again. You're going to come back. And this, I'm only telling you this, I'm spending some time on this because this is very, very important to get your extruder extruding the right amount of material. Otherwise, it can over extrude or under extrude, which over extruding would cause those little gears to sit there and try to push and push and push more filament than it can handle, which will sit there and just dig plastic into those little teeth. Or under extruding means you won't get enough filament forced out of your nozzle to make a proper print. That's why this is so important. That's why I'm spending some time on this, because if you just change those gears and change that all aluminum setup, and that's all you do, you will not get good prints. It will not happen. I'll guarantee it. Unless for some odd reason your factory gear was the exact same size as this aftermarket gear you're putting on. So anyway, repeat this over and over again until you actually have, when you hit the 100 millimeters, you get 100 millimeters worth of reaction out of it. Anyway, that's all I'm going to say about that. Anyway, I'll have the link for both of these, this YouTube channel here and this particular parameter page here in the links down below. I will put that in there for you guys so you can just refer to it, jump down there when you get to this point in the process. Anyway, I hope you found that helpful. Okay, folks, so I want to let you know that I might not have said had all my verbiage right as far as the measurements. Those were just examples I was throwing up there. Please read through the documentation the gentleman has there that I haven't had on the screen. Let me bring that back up. And I can't stress that enough, that you read through this extruder step calibration steps and follow what he's telling you there, because this is going to be the way to do it. This is the right measurements. Just follow what he's saying. I tried to verbalize it as best I can. I might have screwed it up. I'm going to take myself out of the equation at this point. So please follow this as closely as possible. I hope you found it helpful and informative. And that's how you calibrate it. You got to go through a few steps. If you got any questions of how to calibrate the feed rollers, I can do that on my next video, give you a little step-by-step there on how I did it. But I think the one I showed you there is this guy's got a pretty good way of doing it, and I'd say stick with what he's doing. Basically what you want to be able to do is take this Bowden tube off, and when you feed 100 millimeters of filament out, you get 100 millimeters, not 120 and not 93. You get what you get. That way this thing can feed exactly what it needs to feed to do the print. Now I did have a meltdown on this bad boy. I had a failure. Let me show you what that looks like. I was trying to print an owl, and this blue filament I'd got a while back. Well, a while back, I haven't been into printing that long, but I think it's just been bad filament from the word go, because everything I print with it just, and it's just PLA. I ran it at 200 on the nozzle temp and 50 on the bed temp. So obviously it got this far, but then it just plugged. And another thing I noticed is on the rollers, I was getting a lot of blue filament. Even though I got the feed rate set perfect, I was getting a lot of blue filament stuck on here, and I think this stuff was just disintegrating, and then it's crystallized. It's really weird. I mean, it's almost like a sponge, and it's not supposed to be. That's PLA. So I don't know what happened there. If you guys got any ideas of what might have happened, because I printed a bunch of other different colors. I'll show you down here. I've got a variety. Come on, screen. I've got a variety of materials, brands, and colors that I've been using. Yet this is the one that's really acted stupid. I don't know what happened to it. You guys got any ideas what causes that? I have a feeling this might have just been some old filament been sitting on the shelf a long time that got sent to me. And these are reputable outfit that I got it from, but I'm gonna contact them and see what they think. You guys leave your comments below, tell me what you think. One other upgrade that I'm gonna make here while I'm going ahead and changing out this feeder is the Raspberry Pi cooling fan. It doesn't have one. It currently runs, as you can see here, around 50 to 55 degrees, somewhere in that range, which it can run up to 85 degrees, no big deal, but cooler is always better when it comes to electronics. So I'm gonna go ahead and change this. This is the before, and then I'm gonna go ahead and put a little fan on it. Now we're gonna put the fan upgrade on the old Raspberry Pi. In order to do that, I got to remove this screw, and I removed that screw right there. I'll just set it aside. I think that'll allow me to take this other screw loose back here. Yeah, there's another one right back here I gotta take loose. Got those loose, this should drop down, yeah. Now I can lift things up high enough to slide this out. All right. Now I can take now we can take this apart. I was going to take it apart again. All right. See if we can get a fan squeezed inside there. And if this works, I'll leave the link to the fan below. I guess if this doesn't work, I won't be in the video at all, right? We'll just see how many degrees, because I've seen these things climb up to about 60 degrees. Like I said, they can comfortably, I shouldn't say comfortably, they start throttling back. I think it's the right terminology. Once they hit up about 85. And throttling back is not what you want something to do when you're 3D printing. All right. Now they've got that apart. Look at that little booger. That's a tiny fan. But this fan has to go in and hook onto two of these wires, or two of these terminals. Let's see if I can get you in the light here. Two of these terminals right here. And I gotta look up to see which way they go. But this fan should fit right in there, just like that. Guess I want it to go like that. So we'll get our little bitty screws that came with it and bolt that in. You know, I put 4 screws on here because of the incredible torque that these DC fans have, huh? To keep them in control. Surprised the old printer doesn't slide across the table when it kicks in. Oh, those are Phillips. Those aren't hex. Well, guess what? I have a Phillips in the kit. Alright, I'm gonna just make sure everything sits in here without that. Looks like everything will clear without the bolts touching. Oh yeah, all clear. All clear. Now I'm gonna figure out which of these the fan needs to plug into. Okay, as you can see here, you connect the far left one positive and the third one from the far left to the negative. That's for full speed cooling mode. For quiet cooling mode, you can run the red one across from it, bottom left, and then the same ground. We're gonna run the slower one just because I only need a little air movement to cool this thing down. I don't need a lot. And it'll still quiet because I spent all this time making my printer quiet. We're going to use the quiet mode. So that's what we're going to do now. Okay, as you can see, I got the red one to the lower left and the third one from the right for the black one on the upper row. So that'll be my low speed mode. So, and the nice thing is I could reach through here if I wanted to and change it. But I'm pretty sure low speed will be good enough. Alright, let's power it back up. Oh, the little fan took off. And you can't hear it. That's good, that's good, that's good. It's going to blow right down on top of that heatsink though. That's awesome. Let's give her a go and see how she does. Wow, now you can see that that's running about 38.1 C with that little fan on low. that cooled it down quite a bit. Went from 50 to 55 down to 38, and that's while it's running, so that's a significant improvement. I'm running the tool at 220 right now and the bed temperature at 50, but that's at 38 C. Liking that. So the fan is highly effective on that bad boy. Well, folks, that's going to wrap it up for this episode. I hope you learned a little something today. I learned a lot today after having these nozzles stick and getting all gummy on me. And first time I've replaced a nozzle tip. I've gone through probably now 4 to 4.5 rolls worth of, maybe 5 rolls equivalent of printing altogether. I still have a bunch of partials, but they're less than half full. Obviously, a lot of them are. But I'm learning a lot about how materials should and shouldn't act possibly. How to maybe understand when some materials aren't as good as they should be, but I think it's worth honestly taking each new material you get and print you a little test cube and kind of check it, make sure it's doing what it's supposed to be doing before you actually print a large project. I've got to check this out. I designed and printed a flower pot on the CR10. Took about 32 hours to print. Turned out really well. It's got its own built-in water retention tray with a tunnel built into it. So when the water goes in and fills up to a certain spot, it overflows and goes into the catch tray. So I might put that on Thingiverse. You guys let me know if you think that's something that you like to see on Thingiverse. It actually is big enough to, or small enough to print on a Ender 3, but I printed it on the CR10. But it turned out absolutely beautiful. It's clean. But I'm telling you guys, if you show your wife that you can print flower pots, she might be like, hey, maybe we need 2 or 3 of these printers so I can print a whole bunch of flower pots. And guess what? It's a win-win. You get 3 printers, 2 printers, or 1 printer even, and you print a few flower pots, but you also get to play with your own stuff too. So think about that. I don't know, just another way to look at it. You guys get out there and have some fun. I hope this was helpful. We're going to get into some Fusion 360 next. I'm pretty confident in that, and some boat motor parts. I've been promising boat motor parts. I've got one designed. I've got one. We're going to do drawing in Fusion 360. We're going to print it. We're going to show you the start to finish, and we're going to show you where it goes out on the outboard, and we'll go from there. But I have had horrible luck so far printing ABS. I've tried ABS, and I am not having good luck with it. I think I'm going to have to get me an enclosure. Everything I've read it and seen and watched videos on, being open like this is fine, but being closed in a more heated environment is better. But we'll see. You guys get out there and have some fun. This is Michael, and I'm out. Check out what happened to my CR10. Look at that. Completely melted some stuff around everything. So I'm going to try heating it back up and see if I can get this stuff off of there. That's a mess. Looks like it's printing all right. I didn't extrude anything before I started this print, so anyway, we got this one all back together now after that meltdown happened. So don't be afraid to take it apart. It's just simple bolts and screws and everything holding it together. Just be aware that when you turn the heat on, it's going to have a hot end on it. That thing's going to get hot on you. And you guys can also leave any other suggestions in the comments as to what you think somebody ought to do as well. I'm new to this. We're all learning together. But I do have this thing back. This thing lime green now. But I ended up standing these off about 6 millimeters from this back face to where this mounts. And then now this pull is straight across. When you look at it from this angle looking down, it's pulling straight across. It works really well. Puts a nice gentle curve on everything. Nothing's going to pull on at a funny angle and break your filament. Even though it's a filament breakage detector, my goal is to not let it break. So back over here, the dogs just won't quit barking. So we got the new full metal one in place now, up and operational. We got it calibrated. The other thing we put on here was the fan. So I'm happy with that. That actually brings that down quite a few degrees on the temperature. I've actually got the cooling fan now on all three of these. This one just has a different case, but it's got a 40 millimeter fan on it. And the same way over here, I've got the same 40 millimeter fan in that Epic case there as well. So we're having fun with it. Printed a few interesting looking cases, but this is good stuff. This is really good stuff. We're having fun. We've got there again, I'm not 100% convinced this mod is better than the other one, but so far so good. Other than when I did change it over, the bad thing that failed on me was the horrible material that I had in there that did this stuff. And I have a feeling clogged up the tip because I couldn't get it to purge or do anything. I even shoved the clean out tip in there and I could get it to purge and it would stop. So then I just decided I pull this off, replace the tip. We got a new tip in it now. Looks like it's printing absolutely perfect. So we're gonna run that and see how it looks when it's done.